I thought I'd make a video since I haven't posted anything in a little while. I'm sick, but I figured I'd do something somewhat productive. I drove the car around town the other day. Didn't go far. Right now, this is what I have for the intake. I don't plan to keep that. I'd like to make a housing that attaches to the original inlet, and then kind of do something similar, but maybe either like a black hose or just use the metal pipe to attach from that housing back to the throttle body. Somehow I need to figure out how to get a hose clamp around the intake hose. There's not really much room to get any kind of wrench down in there. Maybe I could get like one of those flex drivers through the front, like through here or something, or underneath the ignition coils. Something else I've done is I've mounted a knock sensor. Not really, probably in one of the least ideal locations, but I'm actually having a hard time finding anything on the block to mount it to. So it's mounted through a boss right there at the cylinder head bolt. So, like I said, not ideal. I'm not 100% certain if it's going to pick up knock, but I'm going to try. And since this is just for testing, I just have the wires kind of ran up here. They just go through the door here. The car is filthy. But yeah, they're not ran in any sort of way that I would call permanent. So in the car, I have this app running called Fritcher, and basically it's just an audio analyst app, or audio analysis program. It offers real-time FFT and frequency plotting, as well as seeing the raw signal. My plan is to use this for knock detection. And to connect it to the knock sensor, I just have the knock sensor wires going into, this is a USB audio sound card, I guess. It has I think a 48 or maybe 96 kilohertz sampling rate. So that should be good, since the knock frequency should be around 6,000, because I think these are 95 or 96 millimeter bores. Ideally, the computer would also be connected to the crankshaft position sensor and also know the phase information, so you could window the signal to only capture the knock sensor data after, say, the spark plug has ignited, and usually detonation or knock happens after top dead center, so you might go 0 degrees after top dead center to 30 or 40 degrees and just grab those little snippets. And then you would also know which cylinder is misfiring. I don't have that capability. I suppose I could with like a Teensy or some other kind of microcontroller development board, or just some kind of parallel interface with a laptop. I could probably use MATLAB or Python to do all that. I'm hoping this will work. And basically, I'll just be monitoring the frequencies in the 6 kilohertz range and looking for spikes. Let me go ahead and start the car. You'll see some noise since these are unshielded wires going to the knock sensor, and I probably really should. There you go. That's kind of our noise situation we have here. And some of that may just be due to the power supply for my laptop. Let me unplug it and we can see what happens. Yeah, that helps. Still not perfect, but plug it back in. You see it's got a little bit there. Start it here. So that's pretty cool. You can actually see the pulses. Most likely that's valve noise. Valve noise and combustion noise does look very similar. And because we're at idle, I wouldn't expect there to be a whole lot of combustion noise. I'm having an issue where the car's losing sync right around 4,000 RPM. This is the tooth logger, and let's see here. It's kind of what you would expect the log to look like. You get missing tooth, 2 missing teeth really. So you expect to be 3 times there. 0.4 milliseconds here on the y-axis. These are all the teeth, so you got 0.4, then the missing, and then another missing tooth. That's what it should look like. But this is a problem here. We're missing, looks like 1 tooth. It's skipping. You see that a lot. It starts skipping teeth. Looks like I'm going to have to either hook up the oscilloscope to the raw signal, or maybe I might just try reducing the air gap on the sensor and see if that helps. I did make sure that the sensor I purchased was rated for this frequency, and so, but you know, quality everywhere has gone really downhill, so I wouldn't be surprised if I have a bad sensor or they lied and it doesn't actually have that kind of a switching frequency. I haven't been driving the car a whole lot. Once in a while I'll drive it to work or to a friend's house. It definitely has hot intake air. It runs pretty good. I do need to do something about the crankshaft position sensor. That small 8mm threaded sensor wasn't really working at high RPMs. So I switched to a 12mm sensor that I know works usually pretty well, and it did seem to help a lot, but occasionally at high RPMs around 4,000, it starts missing teeth, so it starts to miss the falling edge of a tooth, and that basically causes the ECU to reset and kind of acts like you're cutting the ignition off, which isn't good because it could be sparking really early. But it doesn't do it all the time. It seems completely random, and I'm almost wondering if the crankshaft is walking forward and back. That trigger wheel I put on, if I had to do it over again, I would definitely recommend going to a thicker, not that thick, but anyhow, a thicker wheel, and also maybe a larger diameter so you have more defined teeth. If you remember in some of those other videos, the teeth on this wheel are very small. If I wanted this diameter wheel, I should have went with the 36-1 tooth wheel. Just that way the teeth could be a little larger. But there's definitely room for a larger diameter, and I think having a thicker wheel. This one's only maybe 1/8 of an inch. I don't exactly remember. I'll have to go back in the videos, but I think that's really what's biting me right now. I'm going to try adjusting the crank sensor a little bit, maybe move it closer, in and out a little bit. We'll see. If nothing else, I'm going to go to a variable reluctance type sensor, which I think I showed some in some of the earlier videos, but they don't care as much about the tooth location. Like if the wheel is a little bit forward or back, it lowers and raises the voltage a little bit, but the zero crossing point should still be the same. Other than that, the car's doing pretty good. Seems to have pretty good power for not really tuning the ignition much. I just kind of interpolated from the manual where it tells you to connect it to vacuum and no vacuum at 3,000 RPMs and the idle points. That seems to be working. It should probably definitely get dyno tuned. But I do run premium gas in it, and I'm not seeing any real values on the spectrogram that I have on the laptop for the knock frequencies. That's pretty much it. I'm going to try to get this intake done, and that'll be a video. It's probably going to be a little slower going now just because the car does run and drive, so it's not kind of the highest priority on my list of other projects and typical vehicle repairs I have to do on my other cars. But if you guys have any specific questions or anything, let me know and I'll try to answer them or make a video about it. So once I get the crank sensor fixed and this intake system fixed, I'll make a video. And I've tried to work on the tune a little bit, but I need somebody to drive me around in the car. Obviously I can't really be driving it and tuning it at the same time. But I'll keep working on it. Like I said, it might just be a slower pace. But I appreciate you guys watching. Thanks.